Hey, Algebra 2. Today we're going to talk about geometric sequences. Geometric sequences. This whole time we've been dealing with arithmetic sequences where we add. So we've been doing 2, 5, 8, because we just add by 3, add by 3. Well, geometric is when we actually multiply. So 2 times 2 is 4, times 2 is 8, times 2 is 16. And on the arithmetic, okay, we had here, sorry, those just look really bad. When we figured out that these were 3, we called that D. Our common difference is 3. But for the geometric, we have a different word for it. We don't call it the common difference. We call it the common ratio. Okay, so we call that R. Our common ratio. So from one term to the next, how much are you multiplying? So here it says for each sequence, that's not a word. For each sequence that is geometric, find the common ratio. So here, the way we do that is take any term, let's take our second term. So take any term besides the first and divide it by the one before it. Okay? So here we have negatives cancel out, that gives us 5. Now let's see if that actually works with another one. So if we did 50, negative 50 divided by the one before it, so negative 10, we also get 5. So, and it works for each of these, so we know that our ratio, common ratio, is 5. Okay? Now in this one, if you take one term, divide it before, we get 2. So this, 6, divide the term before is 4. This is actually 3 halves. So since it's different, we know that this one is not geometric. Okay, not geometric. Here our ratio is 5 because you keep on multiplying by 5 each time, but this one it's you're adding 2 each time, so therefore it's not geometric. Okay. All right. Now it says write the next 3 terms of the geometric sequence 64 minus 32, 16, negative 8. We need to find the next 3 terms. First of all, we need to figure out what our ratio is. So I'm going to take any number besides the first. So I'm going to take negative 32 and divide it by the one before it, 64. Which we could actually reduce this by 32, so it ends up negative 1/2. So this is our ratio, our common ratio. So if we had 64, negative 32, 16, negative 8, our next 3 terms, what it's saying is multiply this term by negative 1/2. So negative 8 times a negative 1/2 gives us a positive 4. Times a negative 1/2 is a negative 2. Times a negative 1/2 is positive 1. Notice, when you're dealing with a ratio that's negative, it keeps switching symbols. Okay? Keeps switching symbols when the ratio is negative. And here we just keep cutting it in half each time. So that's how you find the next 3 terms. Alright, our next problem. Let me go ahead and move this down. It says, find the first 4 terms of the geometric sequence whose first term is negative 3 and whose common ratio is negative 4. So our first term here is negative 3. Now we need to find the first 4 terms. It gives us the first one, so basically we're just finding the next 3. It says your common ratio is negative 4, so that's what you're going to be multiplying each term by. So negative 3 times negative 4 gives us positive 12, times negative 4 gives us negative 48, and 48 times negative 4 is 192. Okay? So this is very basic. We're just multiplying. Again, since our ratio is negative, notice negative, positive. It switches symbols. Alright, and lastly, find the specified term. Okay? Now when we were dealing with arithmetic, okay? Arithmetic sequence, we had a sub n is equal to a sub 1 plus n minus 1 d. So that was arithmetic sequence. Now, for the geometric sequence, we have a different formula here. Obviously, there are different types of problems. So different formula. We have a sub n is equal to a sub 1 times r to the n minus 1. Okay? Where n minus 1 is the exponent of r. Alright, so let's actually I didn't write down what we need to do. Our first problem, we're trying to find the fifth term of, given this information, a sub 1 is equal to 7 and r is equal to 0.2. Okay, so now we need to find the fifth term. So we're looking for a sub 5. Okay, here our first term is 7 times our ratio, which is 0.2, to the n minus 1. In this case, n is 5. So really what we're doing is 7 times 0.2 to the fourth power. So if you can work this out on your calculator, 0.2 to the fourth power is 0.0016. So when you multiply that by 7, okay, times 7, we get 0.0112. Okay, so that is finding the fifth term. Alright, let's do one more. What if you were to find the 10th term given this information? You have the sequence -8, 4, -2, ... So in this case, we don't know what the ratio is. It doesn't tell us r is equal to this, alright, r is equal to that. So we have to figure out what r is. And again, the way we do it is pick any term besides the first, so I always go to the second, and divide it by the one before it. So we have -1/2. Okay? So -1/2 is going to be our ratio. So let's list what we know. We know that n is 10. We know that a sub 1 is equal to -8, because that's our first term. And we know that r is equal to -1/2. Okay? So, a sub 10, our 10th term, is our first term, -8, times our ratio, which is -1/2, to the 10 minus 1. So really, that's -8 times -1/2 to the 9th power. And again, the big mistake that people do a lot is they multiply these two first. But remember, you have to apply the exponent first. So here we have -8. If you were to do this, negative to the 9th power is still negative because it's odd. And 1 to the 9th power is just 1. 2 to the 9th power, on the other hand, is 512. So -8 over a negative, so first of all, those cancel out. 8 divided by 512 is equal to 0.015625. Okay? Because again, this is 8 over 512. Alright. And actually, you could just reduce this. If you want to leave it in fraction form, you can divide both of these by 8. So you get 1 over 64. But I'll accept either answer. So this is what a sub 10 is equal to. Okay? So again, you can reduce, or you can put in decimal terms. So this is what geometric sequences are. Again, remember we're dealing with common ratio. Okay, we're dealing with common ratio now, not common difference. Therefore, it's how far, or what you are multiplying one term to get to the next. So -4 would be our common ratio. Alright? That's geometric sequence. Good luck.